Welcome to this explainer. Have you ever wondered what a simple afternoon game of cricket has in common with, say, a multi-million-dollar space mission? I mean, you probably wouldn't think that a stinging hand from catching a ball has literally anything to do with launching a massive rocket, right? But today, we're going to unravel a pretty fascinating everyday mystery. Welcome to the Momentum Mystery, from cricket balls to rockets. Okay, let's dive into this. Why exactly does a fast cricket ball hurt so much? Just picture it. You're standing out there on a grassy field, the sun's beating down, you've got your eye locked on the ball, and then out of nowhere, smack! You catch it, and your hand is just absolutely throbbing. It's a super relatable, sharp sting, isn't it? Pretty much all of us have felt something exactly like it at some point. But what is actually going on in that tiny split second of impact? Well, this brings us to the inciting incident from our source material. There's this guy, Rahul, and he's just out playing a casual game of cricket with his buddies. He goes in for a catch, and this really fast-moving ball just slams into his hand. Completely caught off guard by the intense pain, he rubs his stinging palm, turns to his friend Aman, and asks the golden question. Why on earth did that hurt so much? Like, what makes that one specific ball cause so much pain? Section 1. Defining linear momentum. Aman's physics lesson. Let's meet Aman, who basically steps up as our wise guide here to explain the invisible physics going on behind the scenes. Take a look at the definition we have here. Linear momentum is simply the product of an object's mass and its velocity. Ayman explains that momentum is, at its core, just mass and motion. If a thing has mass and it's moving, well, it has momentum. And the rule is strictly proportional, meaning the faster an object is traveling, or the heavier it is, the greater its momentum becomes. So sure, that little cricket ball might not weigh very much at all, but because it was traveling incredibly fast, its high velocity just totally skyrocketed its overall momentum. Now, what's really interesting about this slide is how Rahul immediately applies this idea to the real world. Think about a standard bicycle versus a massive, heavy truck. Even if they're traveling at the exact same speed, meaning they have the exact same velocity, stepping out in front of that truck is obviously a completely catastrophic idea. Aman confirms this gut instinct. The truck is way harder to stop simply because its massive weight gives it drastically more momentum than the lightweight bike. Section 2. Controlling the impact. Engineering for momentum. Now we're shifting from just understanding the math to how humans actually manipulate these physics to survive crazy impacts. So how do we actually do that? Well, take Alderman's brilliant real-world example of car airbags. When a collision happens and a vehicle suddenly stops, bam! The airbag immediately deploys. Its one specific job is to artificially increase the stopping time of the passenger's moving body. Because that stopping time gets stretched out, the actual force of the impact is significantly reduced. It's wild to think about, but engineers literally save lives every single day just by cleverly manipulating the amount of time it takes for a passenger's momentum to hit zero. And this high-tech airbag concept brings us right back to the cricket pitch. Have you ever noticed how experienced cricket players naturally move their hands backward while catching a ball? They aren't just holding their hands out stiff, they're flowing backward with the ball. They're doing the exact same thing an airbag does. By extending the stopping time of the ball, they drastically reduce the force of the impact, letting them safely catch it without that agonizing, stinging pain Rahul had to deal with. Section 3. Rockets and Universal Rules. Scaling up the physics. This is where we scale things way out to the grandest application Anand mentioned. And this brilliantly illustrates how momentum works exactly the same way across the board, from a grassy cricket pitch to a car on the highway, all the way up to space exploration. The universe operates on a wonderfully consistent set of rules. Whether you're reducing impact force in sports, using airbags to increase stopping time in transportation, or watching a rocket conserve momentum by expelling heavy gases backward to blast into space, it's literally all connected. A rocket is thrust forward simply because those gases are pushed backward at incredible speeds to balance out the equation. It's the exact same math. This all leads perfectly to Rahul's ultimate realization. He says, and I'll quote this directly, linear momentum isn't just a physics formula, it's a principle that explains everything from sports and transportation to space exploration, making physics a fascinating part of everyday life. Honestly, that is the core of what you should take away from this explainer today. What started as a simple, everyday enigma, just a stinging hand after a bad catch, unlocked an understanding of a massive universal rule. It's amazing how one simple formula can totally transform how we view the entire physical world. So, as we wrap up, I really want to leave you with this question. Where else do you feel the invisible push of momentum in your daily life? The next time you drop a heavy book, or ride a fast train, or even just watch a bird gracefully land on a branch, think about mass and velocity. The invisible gears of physics are turning all around us all the time. Thank you so much for diving into this explainer with me today. Keep observing and keep asking questions about the amazing world around you.